Hi, and welcome to the virtual DevOps conference. I'm Sasha Rosenbaum, and today I'm going to be talking about the Microsoft DevOps journey so far. And in a surprise fashion, I actually work for GitHub. Um, so I actually used to work on the Azure DevOps team for Microsoft. So you will notice that sometimes I use we when I refer to Microsoft, and sometimes I use we when I refer to GitHub, and that's just because of my background. I really spent almost 15 years in this industry, working as a dev and ops, and then architect and program manager. And that's partially because I started working in IT before I finished college, and partially because I'm getting old. So in my spare time, also, I like to organize community conferences. So I am an organizer of DevOps Day Chicago for the last 5 years, I think, and then organizer of the new Delivery Conf. So let's get started by talking a little bit about why companies are so excited about implementing the DevOps mindset. So, we used to use this metaphor of like software is eating the world, but really, most CEOs right now have some type of digital transformation initiative, and the truth is that everyone now is getting into software delivery. Even enterprises that didn't used to have anything to do with software delivery are now very interested in creating better user experiences for their users, having a mobile experience, having a web experience, right? Because if they don't do that, then someone will disrupt their industry by delivering better software. So basically, one of the things that now becomes relevant to a lot more organizations is that software delivery paradox of like, can I have better speed with better reliability? And we used to think that these things are contradictory. So basically, developers wanted to move fast and innovate as fast as they can, whereas ops people wanted to basically restrict changes because changes were breaking things, right? And so we kind of had this opposite incentive. And then basically DevOps practices came around and said, hey, we all work for the same goal. And actually, in the last few years, Nicole Forsgren and team introduced something that is called DORA, DevOps Research and Assessment Reports. And they've actually shown by collecting data from many organizations, that actually the teams that move faster are actually the teams that break things far less. So you can look at these numbers. These are, that 106 times faster lead time for changes comes with also 7 times lower change failure rate, right? So you actually get really good at delivering software if you move quicker, right? Because you develop that muscle. And so speed and reliability are actually not contradictory. The second question is, why transformation, right? Because, we could just continue with the practices that we had. Well, for Microsoft specifically, there's this nice, org chart. This is for Microsoft and other companies, and it's yearly, on point. But especially for Microsoft, folks who used to work at Microsoft, 10 years ago, think that this is very much on point. And there used to be a reason for this, right? Because the big organizations inside Microsoft, they used to not be incentivized to rely on one another's tools, right? So if I'm on a Windows team or I'm on an Office team and I'm shipping software, I do not want to take dependency on the other team. Right? So basically what ends up happening is I build my own tools for shipping software, right? Because I don't want my, my capabilities to be dependent on another team. And so we ended up spending lots and lots of development cycles on developing the same frameworks across different teams. So basically, when Satya took the helm of the company, he said, hey, we must build this one ES, one engineering system, so that we can deliver software more reliably across different teams. And basically what he says is, I would any day of the week trade off features for our own productivity. And this is something that, is a benefit of having a CEO with an engineering background, right? Because if you read the Unicorn Project by Gene Kim anytime recently, then you know that this is a big trade-off, and a lot of times it's really hard to convince the business that features are not more important than technical debt and developer productivity. But we did manage to understand that this is one of the most important things. And I will also show you some things that we potentially did to do that. So our journey so far is where we started. Our first shipped version for Azure DevOps that used to be called TFS. It was in 2010, and before that there was about 2 years that went into developing that TFS server. So basically we shipped that version on DVD, so you had to install it yourself, and actually you couldn't install it yourself. You actually had to hire a consultant to install it for you, because most of the time people tried to install it, it didn't actually work, right? And it was built by a team that then had to take another 2 years to develop another version, right? And this was really, really painful process of delivering software. But in 2012, we delivered the first SaaS version. It was called VSTS at the time. Basically shipped a live site product that people could consume in the cloud. And then there was a bunch of different interesting timeline points. But right now we're on Sprint 166 for Azure DevOps, it's called now. And GitHub got acquired in October 2018. And Microsoft now fully embraces open source. So we have almost 9,000 open source projects and 25,000 employees, Microsoft employees, contributing to open source daily. And now we have this, with the GitHub acquisition, we have this GitHub features fitting in as a piece of a puzzle, right? Which is part of the reason I'm here talking about the Microsoft journey, because GitHub is now becoming part of this Microsoft journey and helping us build that software that Microsoft uses to ship software. So these are just some swag numbers, and Microsoft deploys somewhere about 82,000 times a day, and you will notice that these are not super recent numbers, because we could change the slide every day. But basically, someone somewhere at Microsoft deploys software using Azure DevOps about 82,000 times a day. And that just kind of shows you the scale at which we work, and the scale at which we can learn from the deployments. And then we have about 107,000 engineers inside Microsoft working with one engineering system and with Azure DevOps. So basically, if we save these people 1 second per day, we would be adding 3.7, I don't know what 0.7 is, people to Microsoft. If we save them 1 minute a day, we would be adding essentially 163 more people to Microsoft. And if we manage to save everybody 1 hour a day, it would be like adding 2.7 billion a year to Microsoft yearly revenue. And the thing is, we don't incentivize engineers on these numbers, right? We don't go to an engineer and say, hey, we're going to give you a bigger yearly bonus if you save us more time. But these numbers do let us sort of show folks at the executive level why what we are building is actually important and actually helps the entire company deliver software better, faster, and more reliably. So I want to talk more about what we learned as part of our journey. So one of the things that we learned was that shipping is a feature. So we went through a bunch of different definitions of what done means. So we started with, hey, compiled on my machine, right? Where everybody starts. Then it was like, it is committed. But then, you had to also, run tests on it. Then it was like it's committed into our branch. Then you had to go through merge hell to get it into master. Then eventually when we got into live site, we got into this definition of down, which is like it's live in production, which seems like this would be the end of story, but it actually is not, because it's live in production, but is anyone using it? And are people who are using it happy with it? So right now our definition of done is it's live in production, collecting telemetry, and supporting and diminishing the starting hypothesis. So we do something that's called hypothesis-driven development. So essentially, when a product manager decides to implement a feature, they first collect user feedback and requirements, and then they hypothesize that some feature will be beneficial for the product, and then they work on developing it, rolling it out, and then collecting telemetry to support that hypothesis. We also do something that's called trunk-based development. So basically, everything is developed on very short-lived topic branches, and then pull requests committed into master. And then we do have release branches, which is because it takes us a few days to roll out to all the environments, which we're going to talk a little bit about later. But essentially, all the code goes into master all of the time, right? And so this is important, and this is a practice of most of the elite organizations doing DevOps and continuous delivery, but this is not easy to achieve, and so we're going to talk about a little bit more of things that help us get there. So one of the things that we learned is, hey, you're always going to have some bugs. You're always going to have some things that go wrong, when you ship. And so basically we are controlling the blast radius. So we're doing something that is called ring deployments. So we start with Canary, which is internal users. So it's Microsoft folks that we roll features out to. And again, we said we're super lucky in this sense because we have over 100,000 internal users. So we can sort of test eat our own dog food here. Then we test on the smallest external data center, roll out to largest external data center, roll out to international data centers, and essentially then everyone, right? So basically this process takes a few days, and there's lots of different gates in the process. So this process can stop at any point, but this also means that the same code that started in the first ring ever it is the same code that's deployed into live production for all the rings in the end. And I think there's another presentation today that is going to talk a little bit about gated approvals and different things that you can do with Azure DevOps in terms of going through that process, but this is kind of like part of the complicated flow that we have in Azure DevOps for deploying our code. So I have a question for you. I know this is not live, so I won't be able to see the show of hands, but still want to give you a second to think about this. So do you test in production? Okay, so I actually have an answer to the question, and the answer is that everyone tests in production. And this is a quote from Charity Majors, who works for Honeycomb. But definitely, if you ever shipped a bug into production and then had to go and fix it, essentially you were testing in production. So the difference between organizations that test in production and those who do not is just that one type of organization admits it to themselves that they test in production and the other does not. But so one of the things that people ask me immediately if I say we do trunk-based development and everything's always on master is like, well, if I needed to develop something for 3 months and I wasn't ready to ship it to my users, how could I possibly do that? So the answer to that that we have is feature flags. And so all of the code is always deployed, right? So sometimes we work on something for a few months and people don't know about it yet. But then we can ship it into production and then you can turn on the feature flag and we can launch it, right? So first of all, we can create dark launches. So basically, we can roll out a feature which our users don't even know about to just a subset of users. The other thing is we can control it both on the team side and also on the user side. So we have opt-in preview features, and we actually collect telemetry on who's opting in, who's opting out, and stuff like that. So basically, we can ship the features and continue shipping basically dark code. And this also means that we are not shipping a major chunk of code in a single day, right? This is continuously deployed. So if something were to break, then we would know about it way before, this major release of a huge feature. And then the other thing that we had to learn, this is a muscle that we had to develop, is a lifecycle culture. Right? So I talked about how we used to ship on DVDs. So this was something that was essentially easy for us, right? The moment we packaged the software, we didn't have to worry about it, whether it works or not. And any kind of problem that you might be facing was in your own server, and your own server administrator had to go fix it. But with LifeSite, we always have to make sure that the LifeSite is working, and if there's any kind of incident, then we have to go fix it, obviously. And so site reliability is very important. And this is something that, again, takes priority over all features, right? Because obviously if something isn't working for our users, then there's no merit in developing new features, but we rather need to go and fix our stuff. And then the other thing that's important is iterating over pain, right? So a lot of times when people first start a DevOps transformation, they don't know where to start, right? And usually you should start with the process that hurts the most, right? Whatever irks you and is the most painful and annoying thing that you have to do manually every time is the thing that you should start with. And so basically what we have learned is that there's no such thing as partial automation. So, we used to have these things that are one-offs, and it's like, okay, well, I only need to run this super rarely in certain circumstances. And then, what's highlighted on this slide is an example where someone pasted a command and the quotes were mangled because it was from an email. And so, a staging environment went down because of that. But we used to have all these disparate, checklists and emails and OneNotes and things that people were keeping. And we basically decided that we need to automate completely. And so there's no such thing as one-offs. Everything is automated, including like the rolling security keys and all of these things. So basically, and the other thing that I mentioned is that the pre-production in Canary are always the same as production. So the same code gets basically promoted between environments. And then again, the takeaway from this is if a process often breaks, then do it more frequently. So kind of as human beings, when something hurts, we want to move away from it. But rather, like the lesson in DevOps is that we want to do the process until it stops hurting, right? Develop that muscle so we can be better at it. And then the other thing that we did as a team is we were shifting left on quality. So this is a process that took us a little while. So basically, we created this definition for tests. So instead of calling something unit tests and integration tests and arguing about it, we basically said, okay, there's 4 levels of tests, starting from vanilla unit tests that have no dependencies and ending with essentially the level 3, the front end tests and integration tests, right? And so you can see that like in the beginning of our journey, we had lots of front end tests and then very little unit tests. And over time, we shifted into the lots of unit tests and lots of level 1, which is like dependency on SQL. The reason we did that is that we discovered that the front-end tests were super flaky and we couldn't reliably tell if they were helping us or hurting us. And then also they ran for a really long time. So it took us like 24 hours to run a build because of all the tests, and that was slowing us down. So basically now what we have is we have the level 1 and level 0 run on every single pull request. So again, I think there is another presentation today that is talking about pull request policies and branch policies and things like that. So you will notice that there's some policies configured on this pull request. So before your pull request gets merged, essentially we are running all the unit tests against it. So again, I took the screenshot in Azure DevOps a couple of days ago, but we run essentially 84,000 tests in just a little under 7 minutes on every pull request, which means before your code got committed into master, we ran this many tests. Right. So this allows us to learn about the software quality. And also, this wasn't something that happened in a day. It took us literally 3 years to get to a point where we had this many unit tests and that we could run them in under 7 minutes. And the other thing that was really important to this journey is that we eliminate flaky tests, and we actually added a feature that helps you eliminate flaky tests, because once you start ignoring the reds and saying, hey, it's fine, we can still push it into production, then you essentially, all of the other unit tests are useless, right? If you can't trust your tests, then you're essentially not using them at all. And then so kind of on the software side, on the team structure, we discovered that was also very important. So we used to have development and testing and program management separate. Then we kind of moved to where everyone was called an engineer, and that kind of reduced some of the, throwing bugs over the wall. But then we also did something different, which was called vertical team alignment. So we essentially said, okay, if you need a UX designer, an ops person, and a bunch of developers and a PM on a feature team, that's your feature team, right? And that team is also responsible to deliver the software to customers and to communicate with the customers, right? Gather feedback and stuff like that. And we discovered that greatly increased sense of ownership. So again, instead of silos and people throwing things over the wall, there is a lot of sense of ownership for each feature. And then we do something that's very unique to our team, but it's called a sticky note exercise. So essentially, we let developers once a year or two basically choose which team they're working on, and we usually discover that only 20% of people change, but everyone has a chance. And then measuring KPIs is very important. So we want to measure impact and not activity. So we want to measure the lifesite health metrics, and we want to measure the customer satisfaction metrics. And these are the things we really look at. It's also important to mention what we don't look at. So the things we don't watch is the original estimate, have we met it, or the lines of code. Oh my God, we don't watch that. We also don't watch team burn down, team velocity. I know these are really popular, but the problem with those is they're really easy to game, and then the teams start essentially working on gaming the metrics instead of delivering value. So if you can game the net promoter score for the software, then great, I want to learn from you, right? So we want to look at the metrics that are really the closest to delivering value to our customers. And then we do planning with OKRs, and we have the leadership sort of crafting the big picture, sort of the 12-month strategy, type, and then the teams are responsible for planning and executing on a lower level. So I want to quickly mention what's next. So we talked about our journey so far, and now we're adding GitHub to the journey, so it becomes an important part of what we do. So basically, we now have a joint engineering team between Microsoft and GitHub, which is also part of why I'm presenting Microsoft Journey and wearing a GitHub t-shirt. And so I have one more question for you. So do you use open source? And I, of course, have an answer to that question as well. So everyone uses open source. We have these numbers from some of the reports. So 99% of applications leverage open source software. In 90% of code bases have open source components, which is a lot of times a surprise to big enterprises. But it also means that we have to basically look into security of these open source components every day. So as GitHub, we are uniquely positioned to, because of the wealth of the open source that develop on GitHub, to develop some security tools for that. So we are going to roll out some pretty exciting things. And then we're looking into inner source, so basically, helping organizations break the silos internally and collaborate on code. And then we're looking into resilience engineering, chaos engineering, and stuff like that. And so one of the most important takeaways is that the journey of 1,000 miles begins with a single sprint, and DevOps is not magic, and you can do it. Everyone can do it. You just, sort of start on your journey, iterate over pain, work on what hurts the most, and then celebrate your successes as you go. And thank you so much. And I will be excited to join you in the next presentation. Bye.